Hello, fellow Sublime Text fanatics. ODAT Nerd here with the quick vlog update for the end of Devember 2018, day one. And sorry for the poor lighting in here, but I'm a software developer, not a videographer, and it's pretty late at night. So, what actually happened here on the first day of Devember? I went over the code in the project repository, which should be linked in the description below, unless I forgot, in which case come back later because I'll probably remember later. To point out that I had a server pre-written from an example in C Sharp and also a client command in Python for use in Sublime Text. And the server example was something that was from the .NET API browsers, how to do async socket API in C Sharp, and implemented a simple, probably not overly robust, but good enough for now, Echo server. And I did some quick Googling for Python Echo client, came up with, like the 3 lines of API that you need: create a socket, connect a socket, write some bytes, read some bytes. It was very simplistic, but that stuff I all had set up at the beginning of the before the first day even started, if you will. Whoops. I unclipped my headset accidentally while straightening my shirt. I'm not doing any of the editing on these at all, by the way, except to chop off the beginning and the end. Um, so what was I saying there? I had that code set up right at make sure the volume is good. Day 0 in the repository as a starting base, sort of as my sanity check for how do you actually do networking. And what was changed tonight was, in order to actually do this in a sane way, you don't want the command that you're executing to do socket IO, because socket IO, if you're doing it in a blocking way, takes non-zero time. That's why they called it blocking IO. And in that case, when you run the command, the entirety of the Sublime UI will freeze solid, waiting for things. That's clearly not a good idea of something that should be done. So we don't want that, and we actually first, as a first step towards something better, move that code out into spawning a thread. So every time you ran the command, it would start a thread that sent a message to the Echo server and displayed the response when it came back. And from there, we could move into a more robust system going forward, which is assuming that there should be only one thread, and it should just be always running while the plugin is loaded, which means when the plugin loaded module API endpoint is called, we spin the thread up and it just sits in a loop waiting for something to happen. And when plugin unloaded gets called, we send a message to that thread saying, okay, we're done now, and we leave. And there's a thread safe queue in place currently. And if you want to get that thread to make a connection and send something out, you drop in a tuple with the hostname, the port, and the string that you want to send to the Echo server, and it builds the connection, creates it, sends it, and then asynchronously calls Sublime set timeout in another thread to call back code in the main thread that displays it. So now the code is doing the same thing it was doing before, but in a threaded way, so it's safe. But also, there's just one thread instead of constantly making a new thread for every single time. And ultimately, the goal there is to have that thread make one or more persistent connections, depending on if you're executing a build to one server or multiple servers. You might want to do different stuff there, but if there's just a queue that you drop messages into, then that's a complete black box to you. So you can change how that works behind the scenes. So, as a simple example, we could say the first time you see a host name and a port, make that connection, store that socket for later. Then every time you get a message to the same host name and port, use the same connection. Now it's not creating a connection every time. realistically, what we want is an introduction message saying we're starting a build on a port that would build the persistent connection, keep that connection open until Sublime quits, and all communications would go over that one connection or those other connections. That's down the line. What we actually, to working towards that is my goal is to create the protocol that's going to be used between the server and the client. And sort of spitballed some ideas of how that should work at a low level going across the wire. We want something like uh, an integer, a 4-byte integer that says how big the next block of data is going to be, and then a block of data of that many bytes. And within that block of data will be one message, or for our own purposes, it could be any number of messages, right? But imagine that that block has a defined layout where the first byte is, or the first 4 bytes is some unique message identifier for what protocol message this is. And the rest of the bytes are the binary payload for that. And here by binary, we mean it could be an int as a 4-byte int or a 2-byte int. It could be an actual byte. It could be a string of ASCII characters. It could be UTF-8. It could be Unicode. Could be anything. It's up to the message how it wants to format all that, but it's transmitted as just raw bytes back and forth. And so we would want a class, and this is what we were spitballing, a class that acts as the base for all protocol messages, and that class would then you would provide it, you would create it and set up any fields in it to convey the message that you want, and then put one of those messages into the queue. And one of the methods in that would be to encode its data into that binary block of data for transmission off to the other side. And the same thing has to happen in reverse. When we get a response from the other side and read it, we need to first read those 4 bytes to know how big the block of data is. Read the block, get the first few bytes, know what the message type is, use that to look up what class this is supposed to be represented as on our side, and then invoke either a constructor or some method that knows how to take a binary block of data and pass it to the correct class to get a fully formed instance back. Essentially marshaling an object across the wire, if you will, which is perhaps something that Python can do on its own with a marshaling module or a pickling module or something. But I want this to interoperate with C# on the remote end, and I don't know if there's a defined protocol for that. I haven't really looked yet. That might be a way to go. But that is all that happened today, and the plan, of course, for tomorrow is to continue on in that vein. We'll flesh out those classes and try to get an async messaging system set up, I think is the goal. So basically, a thread that you can has a couple of queues, one that you can drop messages into and they get transmitted to the other side, and one where when the other side reads a message, it puts them into that queue and you can pull them out. And maybe it also does something to send a notification to you to tell you that there's a message there for you to get out. That's the next plan. And as as I said in the stream, I've actually created this sort of system a few times for a very purpose specific thing. So I kind of have some ideas of how I've done it before, how I wished I might have done it in the past. I've certainly never done it in Python. So we're going to see how all that works out. But that is the end of this vlog update for Devember day 1. So stay tuned. I'll be live streaming again tomorrow for 1 hour. And then doing another vlog, and you can see that then. So stay sublime.